All right, so we're going to take a look at some more physics style questions. We were doing this earlier in the course. We were typically taking the derivative and kind of working our way up, but now we have this tool of finding the antiderivative. So we could start with, let's say, a velocity function and work our way backward to find a displacement function. All right, so that's exactly what we're going to do in this one. So it says a particle moves in a line such that its velocity is v is equal to t minus 3, where v is measured in meters per second. Find the displacement function if the particle starts at a displacement of 4 meters. Okay, so like we said in the last ones, we would have started with a displacement function and then took the derivative to find this. So we're just going to go the other way around. So if we start with v is equal to t minus 3, and then take the antiderivative of that, then that'll give us our displacement function. So we'll use s, which we do quite often in math, is equal to, so then that would be t to the power of 2. So just add 1 to the exponent and then 1 over 2 for the coefficient, minus, and then this would become 3t, and then plus c. Okay, so the last thing to do, we just don't know what c is yet, but that's why they actually gave us an initial condition, right? They say it starts at a displacement of 4. So that implies that time is equal to 0, and then distance is equal to 4. So that's like a point of ours. So let's plug in 0 for t and 4 for d. So 4 is equal to 1 half times 0 squared minus 3 times 0 plus c. So we get c is equal to 4. Therefore, our displacement function, so I'll write it as c or s of t, is equal to 1 half t squared minus 3t, and then plus 4. All right. How far does the particle travel in the first 5 seconds? So be careful on this. It'd be quite tempting just to plug in 5 in place of t. But if you've taken physics 20 or 30, then you might see what the problem is. Maybe not. It's because it's saying how far does the particle travel, where this function gives us our displacement. So you can imagine like what's happening here is we've got some particle and it's traveling this way, and then it's going to like come to a stop somewhere, turn around, and then come back, right? Well, what this equation does is if I just plugged in 5 in this, what that would do is that would just give me, from this point, it would give me my displacement from here to here, right? So that would be like my value from there to there. But really, by the wording of this question, how far does the particle travel? It really seems like what it's after is more, the distance from there plus the distance from there to there. Okay, so this can be a little bit trickier, so we just gotta be careful. So now, what we're gonna do, let's say, okay, how far? What's our like position at time 0? So I'm gonna go s of 0. So where is that? Well, that was pretty easy, right? That's where we start. So that's 4. That's just plugging 0 in for t. Okay. Okay, so from there, though, I'd like to know, with my little picture I just had drawn there, where does this thing turn around, right? So if it's going this way, it's going to come to a stop and then go back again. So I want to find like the time that coming to a stop happened. All right, so to do that, what we're going to do is look at our velocity. Okay, so we'll say, okay, velocity is equal to t minus 3. So we want to know where the velocity is 0, like where it comes to a stop. This is also like where the derivative is equal to 0, right? Like where our slope is equal to 0. So we're really just finding our critical numbers here. So t minus 3. So we're really interested in when the time is equal to 3. Okay, so that's what we're after. So let's find, so we know that this thing turns around at t is equal to 3 seconds. Okay, so let's find that. So using our displacement function there, at 3 seconds, we end up getting negative 0.5. I'm not going to plug it all in. I think you guys could do that, right? Just plugging in 3 for t. Okay. All right, so that's how far. So let's make a little bit better sketch here. So if this is 0 and this is 4, this is where I'm starting. And, this is negative 1. Then our very first journey after 3 seconds goes from here to about here, right? Negative 0.5. Okay, so how far would that have been? Well, that would have been 4 plus 0.5, right? Like the absolute value maybe of 0.5. But either way, we went 4.5 meters in that direction, okay? And so this is like a distance. I don't actually care about direction at this point. All right, so from there, let's say, okay, what is S of 5? So after 5 seconds. So S of 5 is 1.5. All right, so where's that? So if this was 1, then we're past that one. So as we turn around, we're going from here, and then we're going to right here, let's say, right? So to a distance of 1.5. Now just careful here, right? Because at this turning point, like where we turned around, we were at negative 0.5. And I went to like the marker of 1.5. So this is actually 2, right? This is actually 2 meters from there to there. Hopefully that makes sense. Okay, so in the end here, it was just 4.5. So our distance would have been 4.5 plus 2. So it would have been 6.5 meters.